So the next thing we need to talk about is we need to talk about what happens when light travels through a material. We've seen how light travels and strikes the material and bounces off in a law of reflection. But part of that light, if the material is translucent or more appropriately transparent, because we're not going to talk about the translucent model, but transparent, which allows light to freely travel through, what happens? How does that, how does light behave in that case as it's traveling through that material? So that's what we're going to talk about. So let's talk about the same kind of thing. And this time I'm going to use a piece of transparent material, either water, glass, something along those lines. Okay. So here's my surface of interaction. Okay. So everything below here is water, and everything above here are glass or whatever you want it to be. And there's actually a solid line there, but it's just not coming in very well. And over here is air. Okay? So my light is going to come in, and it's going to strike that water. And we know from the previous video that it's going to strike that water at an angle. Okay? And we call that the angle of incident because this is an incident ray. Now, there's a reflected ray that bounces off that and goes up in that direction. Whenever light has an impact with that surface, a portion of it is always going to be reflected. Okay, so not all of it is going to transmit through that material. A portion of that is going to get reflected. It's just a situation in which we're going to have to deal with. Okay, so a portion of it strikes that surface and reflects, and we know that about water. We know that when light comes in and strikes the surface of the water, it bounces off. I mean, if you've ever been in a boat in a hot day, you get blinded by the amount of sunlight you're getting because it strikes that surface and then bounces back into your face. So not only are you getting the sun coming down on you, but you're getting the light that's hitting the ocean and coming back into your face. Now, part of that is also transmitted through the water. So you get what's called a transmitted wave through that water. Okay, so it enters that water, and we just call that transmitted. And it's also referred to as refracted. It's not a refracted ray, it's a transmitted ray. Right? But this process is called, this is reflection. As the beam comes in and strikes and goes to the water, it's called refracted. Okay? So that ray ends up getting refracted in that water. Okay? Now, important thing to note is that this angle here that's being transmitted, this angle is not equal to this angle, which is also not equal to this angle. So this angle and these two angles don't necessarily have to be equal to each other. We know that this one and this one are equal, but this one's not equal to either one of those. Okay? So it's its own angle. Transmitted, and why that happens, just letting my camera catch back up. Why that happens is that there's a phenomenon that happens when it enters that material. Light enters that material and appears to slow down. Okay? It appears to slow down as it's traveling through that material. Now, we know from relativity and Einstein's postulates that that's not possible. Light is always 3 times 10 to the 6 meters per second. Okay, or 3 times 10 to the 8, not 6. 3 times 10 to the 8 meters per second. It's always that. Okay? So what ends up happening in this material, this material in which it's being transmitted through, is that it's absorbed by the particles of that material, be it water, be it glass, be it whatever, and is re-emitted. So there's a time delay there. So it's being absorbed, then re-emitted, absorbed, being re-emitted. And that tends to give the appearance that light slows down in that material. And it really doesn't, okay? It's traveling 3 times 10 to the 8 meters per second between particles. As it goes to the next particle at a velocity of 3 times 10 to the 8 meters per second, and then gets absorbed. And then goes to the next particle. Okay, so that whole absorption and re-emission is slowing down light, or give the appearance. Now, how we determine this angle is what we call Snell's law. Snell's law and I'll walk you through this in the next video, what that angle is. It will tell me what's going on in this system and how we can mathematically predict how that light is going to behave when it travels through that medium. Okay?